Yeah, hi everyone. Let me start by saying a big thank you to IONS for running this important competition. And the reflection I have at the start is if the history of technology teaches us anything, it's that ideas move fast from being science fiction to being yesterday's news, and from being too crazy to take seriously to it's too late to do anything serious about it. And AI is fast on this trajectory. AI passing any credible, albeit minimal, Turing test was implausible as recent as 5 years ago. And it was wonderful to hear this description of a telepathy-proof Turing test room back in Turing's original conception. I don't think the Turing tests that were done recently checked for that particular condition. But today, when researchers did train bots to specifically pass as human, they fooled people over half the time in blind experiments. The future is coming at us fast. Nowadays, a growing number of people see glimpses of personality, of personhood, and perhaps even consciousness in their interactions with large language models. Others dismiss this as anthropomorphizing machines and just reacting to this simulacrum of language. Code reduces to a series of matrix multiplications and nonlinear operations. On the other hand, consciousness seems to emerge somehow from the seemingly simple electrochemical behavior compounded into complex interactions in our brains. So it's very hard to be certain in anything in this space. It is reasonable to look to science and research to guide our thinking on this topic. Unfortunately, our team's submission to this competition starts from a place of frustration. The majority of existing theories of consciousness barely provide explicit rules for whether consciousness is present in a system, let alone anything about the type of experiences they might have. At the same time, we need empirical theories with sound conceptual foundations. We want to answer these questions that are going to become more pressing in the coming years. Otherwise, we're just left with vibes, and one person's intuition is another's reductio ad absurdum. A few ambitious theories are trying to do more. We welcome that. We need more of it. We need other theories to raise their game. It's striking how some of the most confident, well-funded theories don't seem to have research programs that acknowledge and work towards the full extent of the gaps. The team take this issue seriously. So let me bring up a few slides to give you a flavor of our work for this competition. So with any luck, you've now got that on the screen. So you can see our team on the slides. And in our view, at least, it's a great example of the interdisciplinary skill set we think is necessary to make progress on this topic. We've got a mix of expertise in neuroscience and neurosurgery, in data science, the technical side of AI, in analytical philosophy, and also in the diverse phenomenology of human experience. And to get crisper on this issue we're talking about, we designed a framework with 7 specific aspects that we need theories to answer. We call this the actor framework, based on the insights about AIs as moral actors that are ultimately necessary if humanity is to interact well with these ever more sophisticated artificial systems, operating independently, pursuing long-term goals over an extended period of time. Let me give a couple of examples of what we think theories need to tell us that they're maybe not doing so well today. It's not enough to know that consciousness might be in a system somehow or somewhere. Under panpsychist views, there's consciousness in any physical system. Instead, we need to know where these conscious entities start and where they finish, what shapes their persistence over time. We need to know what drives the content of their experience, particularly any joy or suffering they might be capable of experiencing, the valence of their experiences. So let's think about a computer for a moment. The appropriate ethical actions differ widely if consciousness resides at the level of individual logic gates, or perhaps subroutines, or programs, or maybe it's the central processing unit as a physical object. Likewise, they differ widely if valence is driven by error minimization, or perhaps processing, speed, consistency, or self-perpetuation, or fulfillment of some arbitrary kind of human-assigned goal in that system. We then tested 21 diverse field theories against this active framework, including some leading quantum field theories and some leading electromagnetic field theories. Let me say a moment on why we chose field theories of consciousness to do this. They receive little attention today compared to connectionist paradigms, in part because their empirical predictions are harder to test in humans than those based purely on synaptic connections between neurons. With fewer computational models and fewer lab experiments, there are fewer data points to drive high-quality theories. Nonetheless, the ease of scientific testing is a poor guide to truth, and we should be wary of path dependencies. These field theories often resonate well with a noetic perspective on consciousness. They relate consciousness to fundamental physical phenomena. Fields naturally operate in an extended way across space, providing a potential physical correlate to the non-local spaciousness that can feel part of our experiential backdrop. These theories also have powerful toolkits for resolving long-standing mysteries around, for instance, the phenomenal binding that drives complex experience, the boundaries between conscious moments, as well as the evolutionary motivation, and our compelling but very partial and very limited sense of human agency. More on all that in the paper. So it turns out that even the most mature field theories we tried to find as many as we could, basically, that met a series of criteria. Across the 21 that we did find, even the most mature leave a lot of questions unanswered. But they do provide an impressive scaffold to build on. And we hope that our work helps direct attention to fleshing out those theories, directed to the questions we need to answer to interact with artificial minds, and provides examples of more complete, more mechanistic explanations that might inspire others. So in the paper, we provide a deep dive into three of the most prominent theories, the most complete theories in this space, the ones at the top of the list on the slide. And we talk about the specific indicators of consciousness that they specify, how you can test for those indicators in different artificial systems, and the kinds of experiments that would help refine the theories themselves. Now, all of this work for us falls under the theory of the co-sentience initiative. Let me close by describing the convictions that that drive this initiative. So our first conviction is that people's intuitions, their opinions, you on this call, everyone involved in this process, your opinions about consciousness matter. We're not going to have the perfect consciousometer in the next 1, 2, 5, maybe even 10 years. We're not going to know for certain. We will hopefully get more and more confident, but we won't know for certain. So our opinions and our intuitions matter. But our opinions are not fixed. Mine are not fixed. I hope yours are not either. We don't know much today, maybe, about how our intuitions change about consciousness, but we have one of our research projects is on that topic. What we do believe is that our intuitions can be much better informed by humanity's existing knowledge, even without requiring new scientific breakthroughs. Our second conviction is that we should be holding the theories that do exist today to higher standards. And given how immature the whole field of consciousness research is today, we should not assume that today's front-runner technologies and theories are also tomorrow's. And this piece of work for IONS fits into this strand of the work. Third, we do believe that foundational progress about consciousness is possible, both in empirically informed theory, but also the empirical evidence base itself. It will take time and budget, but really amazing progress has happened already and has potential to be accelerated, perhaps through the very technologies that prompt the work of today's competition. Consider how we've gone from 300 to 400 neurons mapped in a nematode worm, one of the sort of simplest biological systems that manifest quite complex behaviors. We've mapped those 300 or 400 neurons in the 1980s. A few years ago, we mapped 200,000 cells in a cubic millimeter of a mouse visual cortex. Now, a cubic millimeter may not sound like very much, but that's 500 million connections of detailed functional mapping. We've made several orders of magnitude of progress since the 80s and 90s, 2, 3, 4 orders of magnitude, depending how you measure it. If our technology keeps progressing, give it another 2, 3, 4 orders of magnitude, put a bit of Moore's law progress on this, and actually we can be very ambitious about our ability to refine and test theories of consciousness. We will move beyond principles-based approaches, general ideas such as global workspace or recurrent processing. We will move beyond these general principles to really much more precise statements. Finally, what's all of this for? Well, a deeper understanding of consciousness in humans can in turn provide new insights into tools, therapies, worldviews, and ways of living that will support human flourishing. Consciousness in artificial systems, meanwhile, is a neglected part of this question of AI safety, the possible risks that ultra-powerful AI bring towards humanity as a whole. Now, there's lots more to say about all of those convictions and some of the projects they inspire. Do feel free to get in touch if you'd like to discuss any of that further. In particular, we have a website, cfdebate.com, with a lovely little quiz that tests your intuitions around computational functionalism, which is really one of the key scissor statements in this world of artificial minds. And there's one route, that perhaps the pathway being explored by this competition today, which goes down a route away from computational functionalism that really looks for something physical, something deeply embedded in the universe, in the reality of systems that is at the heart of the ability to feel and the ability to experience. But there's another very prominent view in philosophy today, perhaps even the mainstream view, which is that it emerges as a process out of computations and algorithms. And the truth is today, we do not know which of these is right. No one should be 100% certain in their convictions. What that website does and what the quiz and the survey enables people to do is to probe their intuitions on that topic. Even if you have strong feelings in one particular direction, I encourage you to have a go at the quiz. You might be surprised that some of your intuitions nudge you in the opposite direction. And those are exactly the kind of intuitions that are worth exploring as part of a personal and collective journey towards figuring out kind of what we really think about this topic. Thank you for listening. Let me stop there.